If you have been following this series, we have already built a strong foundation. We started with understanding how the procedure coding system is structured. Then we went deep into root operations, where the focus was not on procedure names, but on the objective behind what is being done. If you have not watched those yet, I would strongly recommend go back because everything we are doing today builds on that understanding. I will also be uploading a separate video where we'll look at all the seven characters together so you can see the complete picture in one place. But today we are going to slow down and focus on the last three characters: approach, device, qualifier. And this is where coding start to feel more mechanical and more interpretive. Okay. So when you code a procedure, identifying a root operation gives you the core idea, but that is only one part of the story. Two procedure can have same objective, but the way they are performed can be very, very different. How the surgeon reaches the structure, what is left behind in the body after the procedure, and how the procedure is further specified. All of that is captured in these three characters. So instead of trying to memorize definition, we are going to understand how to think through them. Let's start with a real example: open reduction internal fixation of femur bone. Now, when you hear that, do not jump into coding immediately. Just look at this word: open reduction internal fixation. And if I'm reading this in an operative note, the first thing I'm asking is what is actually happening here? Because this is not just a random procedure name, this is actually describing how a fracture is being managed. Let us slow this down for a moment. When a fracture happens, the bone is no longer in its normal alignment, it is displaced. So, the goal is not to fix it, but to restore structure and function. And there is where three principles of fracture management: reduction, fixation, immobilization. In reduction, we realign the displaced bone fragments. In, in fixation, we hold the fragment in a position for healing. And in immobilization, we limit the movement to protect the healing. Let's start with reduction. Reduction simply means bringing the broken bone fragment back into their normal anatomical alignment, because when a fracture occurs, the piece of bone are no longer where they should be. They may be angled, rotated, or shifted. So the first step is to realign them. Now, this can be done in two ways: closed or open. In closed, bone is manipulated externally without opening the body, or in open reduction, where the fracture site is exposed. In open reduction, the fracture site is exposed, the alignment is achieved under direct visualization. So, once the bone is aligned, it need to be held in place. That is fixation, because alignment alone is not enough. We leave it like that, the bone can move again. So, fixation provides stability. It keeps the fragment in position while healing begin. This can be done internally using screws, plates, or rods, or externally using a frame. And in this case, we are dealing with internal fixation. And in immobilization, we limit the movement so the healing can take place without any kind of disturbance. This could be through a cast or a splint, even through a stability provided by internal fixation itself. So, if we simplify everything, fracture management come down to three steps: align the bone, stabilizes the bone, and protect the bone. Okay, so returning to our case, open reduction internal fixation of the femur. Now the name itself start making sense, right? We are aligning the bone by exposing the fracture, and we are stabilizing it using devices placed inside the body. So instead of memorizing the term, now we can, you know, visualize the procedure. So now coming back, how did surgeon reach the fracture? If it's open reduction, what does that tell you? That body was open, the fracture site was exposed, and the surgeon directly visualized the bone. So now we do not have to guess. The approach is open. Approach is simply the way surgeon reaches the site of the procedure, not what is done once they were inside. Now, not how complex the surgery is, just the path. I want you to start thinking like this whenever you read a case. First, take a pause and ask one question. How did the surgeon enter the body to reach this structure? If you can answer that, you can determine the approach. In open approach, the body is physically open, the structure is directly visualized, and this word visualize, directly visualize, is very very important. Surgeon is not relying on any imaging alone. They are not working through a small access point, they are looking at the structure with their own eye. Now, this is where interpretation becomes important, because many people try to decide approach based on incision size, but this is not the correct way to do. A small incision doesn't automatically mean percutaneous. If the structure is still directly visualized, the approach will be open. Now, imagine a different situation, a small fracture, but instead of exposing the bone, a rod is inserted through small entry point, guided by imaging. So the bone is not directly visualized here. So the now approach changes. Approach is not the name of the procedure. It is not how big or small the incision is. It comes from one simple thing: how the surgeon assess the structure and whether they could directly see it or not. Once you start thinking like this, approach becomes very very easy. Before we move forward, let's quickly see this what we have built. uh, we have seen like approach is not the procedure name, it's not about how complex the surgery is. It comes to one simple question: how did the surgeon reach the structure? And we saw that when the structure is directly visualized, the approach is open. Now, because open is one part of the picture, the real clarity we can get if we can distinguish it from everything. So now let's move to a situation where body is not opened in the traditional sense. This is where people usually start to hesitate, not because the concept is difficult, but because the thinking is not anchored properly. So again, do not memorize, stay with the same question: how did the surgeon reach the site? Let's start with percutaneous. Percutaneous means entry through a puncture or a small incision without directly exposing the structure. So here the surgeon is not opening the body in a way that allow direct visualization. They are accessing the structure but not exposing it. Imagine inserting a needle in the body. You're reaching the structure, but you are not opening the body to see it. You are relying on guidance, not direct vision. In open, you see the structure directly. In percutaneous, you do not. This is the difference. Think about needle biopsy. The needle enters the body, a small sample is taken out, but the structure is not directly exposed. So, in that case, the approach is percutaneous. Percutaneous is entry through a puncture without direct visualization of the structure. Now, let's add one more layer, because this is where confusion begins. What if body is not open but the surgeon is still able to see inside? This is where endoscopic visualization come in. So now we have entry through a puncture but visualization through a scope. This becomes percutaneous endoscopy. So now we have three situation: direct visualization open, no visualization percutaneous, visualization through a device endoscopic. Think of laparoscopy, small incision, camera inserted, surgeon not opening body, but able to see the structure through a screen. So this is not open and not purely percutaneous. It is percutaneous endoscopic. Now let's take a different situation where what if there is no incision, no puncture, and surgeon uses existing opening of the body, that is natural opening. Think of procedure done through mouth, urethra, rectum. The body is not being cut, it is accessed through a natural pathway. Let's us take colonoscopy. The scope is inserted through the rectum, no incision, no puncture. So the approach is natural opening. Now, if the same procedure uses a scope for visualization, it becomes natural opening endoscopy. So again, do not memorize this. This is separate criteria. Just think, how do we enter? How are we seeing? Okay. So what was the body opened plus structure directly OC? So ask the question, was the body opened and structure directly seen? Then it's open. If there is an entry through puncture and no direct visualization, is percutaneous. If there is an entry through puncture and scope for visualization, that is percutaneous endoscopic. If then there is just an entry through natural body opening, that's natural opening. If we have a natural opening plus scope, it's natural opening endoscopy. Okay, now that we have understand how the surgeon reads the structure, let us move to next question. After the procedure is done, what remains inside the body? And that brings us to device. Device is one of the simplest concept in the system, but it is often overlooked. A device is anything that remains inside the body at the end of the procedure. The word remain is the key. Let us go back to the same case, open reduction, internal fixation. Once the procedure is complete, what is still inside the body? You have a rod or a nail, screw, plate, possibly graft. These are not temporary, they remain inside the body. So these are devices. Now compare that with surgical instrument. Retractors used, drains used. These are used during procedure, but they are not left behind. So they are not devices. When you read a operative note, do not try to memorize devices category. Just ask, when the procedure is over, was it still inside the body? And this is where clinical understanding helps again. Devices are not just placed randomly, they are used to support a structure, replace a function, and maintain patency, provide stability. So, when you see a device, think about it, why it is there. So, now we do have two layer approach, tell us how the surgeon reads the structure, device tell us what remain after the procedure. And once you see these part of the same story, coding become very, very logical. Now, let's move forward and connect these two pieces we already have to a real case. We understand what is happening clinically, then we translate that into coding. We said approach tell us how the surgeon reaches the structure, devices tell us what remain in the body after the procedure. Now there is one final layer, and that is where coding become more precise. This is qualifiers. Qualifier is not something you start with, it is something you add at the end. It does not define the procedure, it refine it. If you think of the procedure as a story, qualifier is the detail that completes the story. So what is qualifier? Qualifier is detail that complete the story. It add precision, not definition. For example, biopsy. Okay, you already know what was done, where it was done, how it is reached, what is left behind. Sometimes that is still not enough to fully describe the procedure, right? Let's see biopsy. Tissue is being removed. So if we look at root operation objective, we say excision, and this is correct. But now, why was the tissue removed? Diagnosis. And that intention is captured in qualifier. So now the procedure is not just excision, it's excision for a diagnostic procedure. So qualifier is not about what was done, it's about adding meaning to what was done. Okay, it answers a simple question, why it was done and what specific variation of the procedure was performed and what additional detail complete the description. Let's take another example, bypass. In bypass, we are rerouting the flow of the blood, and this is not complete story. From where to where? That detail captured by qualifier. So now the procedure become more specific. If it's not just bypass, it's bypass from one location to another. Now let us look to a procedure we have touched earlier, spinal fusion. We know the fusion means joining structures to make them immobile. But these are different type of fusion, like different technique, different approaches to achieving the outcome. And those details are captured by qualifier. So again, the root operation gives you objective, qualifier give you specific type. Now, there is something left that we need to understand here. Not every procedure require a qualifier, and that is where people sometimes overthink. You do not need to add a qualifier unless it is defined in the coding table. So, qualifier is not something you force, it is something you recognize when it is needed. Okay, so let us bring everything together now. When you read an operative note, do not try to code everything immediately. First, understand, okay? And then we will translate clinical written things into codes. First, what was done? That is root operation. Where was it done? That is body part. How was the structure reached? That is approach. What remain after the procedure? That is device. What device, what detail complete the picture? That is qualifier. This is your entire system of PCS. Now let's go back 1 minute to the original case. Open reduction, internal fixation of the femur, ORIF. What was done? Stabilizing using internal fixation. How it was done? Open approach. What remained? The fixation device. Now, if there's any additional detail left that needed to be captured, sometime there might be, sometime they may not be. So, this is where you look at table. What I want you to take away from this, it's not a list of definition. It is a way of thinking. Coding is not about memorizing terms or the guidelines. It's always about understanding what is happening and translating that structured system. So now let's again go back to the five complete question. What was done? Root operation. Where was it done? Body parts. How was it reached? Approach. What remains inside? Device. What detail completes the picture? Qualifier. Okay. Now let us shift the way we are thinking. Till now, we have understood the concept, but coding does not happen in isolation. It happens when you are reading a real operative note with multiple detail, multiple step, and sometimes incomplete clarity. So in this part, we are going to go through cases, and the goal is simple. When you read a procedure, you should be able to break it down naturally. When I read an operative note, I do not start with code, I start with question. And these are always the same. What was done? Where was it done? How was it done? What remain inside? What detail complete the picture? If you stay with this question, you will get your answer. Okay, now let's go to again ORIF. Let's not rush. What is happening here? Fracture, bone is displaced. So it is aligned and then stabilized using internal fixation. What was done? Stabilization of fracture using. So next question, how did the surgeon reach the fracture? The fracture was exposed, the bone was directly visualized, so the approach is open. Now next, what remain inside the body? The fixation device, the rod, screws, plates that give us the device. Okay, now the final question, is there anything, any other detail need to be captured? Now let's take a completely different type of procedure, colonoscopy. Again, do not jump to the conclusion, think step by step. What's happening here? Colon is being examined. What was done? Inspection. Now next question, how was the structure reached? The scope is introduced through rectum. There is no incision, no puncture. So approach is natural opening. Because the visualization is happening through a scope, it become natural opening endoscopic. Now, what remains inside the body? Nothing. So there is no device. And if biopsy is taken during the procedure, then the qualifier becomes diagnostic. Let's see spinal fusion again. What's happening here? Two structures are being joined to make them immobile. What was done? Fusion. Now, how it was reached? in most cases the spine is exposed, the approach is open. What remain inside? Hardware, screws, rod, graft. So give you the device. And now the important question, what type of fusion was performed? The detail is captured in qualifier. So here you can see clearly. Now let's step back and look at these cases together. Same system, different procedure, but the thinking remain the same, right? In every case, we are asking how did the surgeon reach the structure, what remain inside, what detail complete the picture, and that consistency is what going to make your coding reliable. Okay, now one final thing from coding to auditing. When you are auditing a case, you just not assign code, you are validating them. So the question changes slightly. Okay, is this approach supported by documentation? Is this device clearly described? Is this qualifier justified? Because every code must be supported. Okay, so every code element like approach, device, qualifier must directly supported by the operative note documentation. That's the way you see. This is where interpretation usually start to break. Sometimes the approach is assumed without carefully reading how the surgeon assess the structure. Sometimes devices are missed because they are mentioned in passing, and sometimes qualifier are ignored because they seems optional. But each of these changes how the procedure is represented. So let's simplify everything one last time. What you do when you read a procedure, do not rush to code, pause and ask what was done, where was it done, how was it done, what remain inside, what detail completes the picture. This is the entire system. And once you start thinking like this, coding stops feeling like a set of rules, guidelines, and anything that you need to memorize. It start feeling like a structured way of understanding what is happening in the body. And that shift, it's makes everything easier. Okay. I hope this helps. And if it did, just like, share, and subscribe. Thank you.